Hey there, Year 12s. We're now looking at modeling an annuity with a recurrence relation. So here, this is a pretty straightforward problem to do. Reza plans to travel overseas for 6 months, and he invests $12,000 in an annuity that earns interest at a rate of 6% per annum, and providing him a monthly income of $2,035 per month for the 6 months. So, before I write down the answer for this, I need you to understand what annuity means. So annuity, think of it as Reza is now traveling, all right? He's got $12,000 in his pocket, but instead of just using the $12,000 overseas, what he thinks of doing is, well, a bank says, hey, why don't you give me your $12,000? So the bank will get the $12,000 and they can use it for whatever it is. They loan it out, whatever it is, right? And you're like, well, what do I get benefit if I give you $12,000? And the bank says, all right, well, how about you will get your money back. So every month we're going to pay you $2,035 per month up until, we pay all of your $12,000 back. And you're like, well, I can just use the $12,000. There's no incentive why you need to keep my money and only pay me $2,035 every month. So they say, all right, well, how about I pay you back your $2,035, but for whatever every month, I will also give you extra 6% per annum rate. Okay. So 6% per annum rate, that's what you get extra. Okay, so it's the reverse of reducing home balance loans, right? So in this case here, you get $2,035, which is from your $12,000 originally, plus 6% per annum, right? So how do you work this one out as a recurrence formula? Well, V naught is how much you start off with. Well, you started off with $12,000. It's what you began. Now the recurrence rate, Vn plus 1, tells you that they are doing 6% per annum, but since they're doing a monthly income, you need to work out the rate for per month. So the rate for per month would be then 6 divided by 12, which is 0.5. So that's 0.5% per month. That's the rate. Okay, so going back here, I would then say the amount that I am multiplying would be 1.005 really times R. So for those who forgot from exercise 9b on reducing balance loans, R is equal to 1 plus R over 100, which is your rate. So it's 1 plus 0.5%. So 0.5 over 100. So that's 1 plus 0.005. Okay? And that's how I got my 1.005. Okay, that's going back to exercise 9b. So I know I'm multiplying so it's not R, my Vn, which is the initial amount or the previous amount, and then I'm also minusing 2,035. Okay, so essentially what I'm trying to say here is this is the interest you earn, okay, because they're giving you an extra 0.5% on what you originally have, but then remember they're also returning back your $2,035. That's the returning of what you deserve that you could have done yourself anyway, but as an extra, the 6% per annum is what they're adding on top. Okay, so every month now, you will follow this recurrence formula, which if I do it on the calculator just so you can see, you start off with $12,000, right? And you are now getting an interest at times 1.005. We worked out it was 0.5% per month. That's the extra that they're paying you, right? So times that to the 12,000, that's the interest they give you extra on top. But remember, they're also repaying you back your $2,035 because you left the $12,000 with them, right? So obviously you're reducing the 12,000 over time, but because they're giving it back to you with extra, right? So that means now the bank has only $10,025 left to continually give back to you. And remember, they benefit because they get to hold on to your money. Right now, you don't have the $12,000. They're giving it back to you over time plus interest. Okay, so in the long run, you will gain more in overseas more than the $12,000 that you initially started off with. It's just that instead of having $12,000 immediately, you get your $12,000 and more after 6 months. Whilst all the while they're still using your $12,000 to, I don't know, do investments or loan it out to someone else and earn interest from there. So that's what annuity is, right? So you can see after 1 month, that's how much you have left over. And if we continue the pattern in the recurrence formula, after 2 months, after 3 months, after 4 months, after 5 months, okay, so they're returning your money, and they've got $2,025 left. And when they return it on the, how many months is that? That's 1, 2, 3, 4, 5, 6. After 6 months, okay, so clearly there's still 88 cents left that they still owe you. So usually in that last 6 months, they're not going to give you another payment of 2,000 something. They might as well just take that 88 cents and put it into the last payment. Instead of their last payment being $2,035, they'll add on that extra 88 cents as their final payment back to you. So after 6 months, you would have gained not only your $12,000 plus whatever interest you earned in that time. Okay, so that's essentially what annuities is, and that's what example 11 wanted you to do to start off with, is to understand how the recurrence formula works. Okay, so what I've just described here hopefully will help you understand example 12. Okay?